So data was collected for a sample of 1,000 pregnancies and it's contained within the file for download. We need to determine if there is evidence that on average the weight of a baby of a mother who smokes is less than that of a mother who does not smoke, and we're going to use alpha equals 5% for our level of significance. So let's start this off by drawing ourselves a little diagram of the populations. So we have two populations that we're interested in. One is the population of, smokers, and the other one is non-smokers, and that's what we want to compare. So specifically, the thing that we're interested in is the birth weight of babies from these two different groups. So for the population of smokers, let's call that average birth weight mu1, and from here, the average birth weight from non-smokers is going to be mu2. And what we're going to do is draw observations as a sample from each of these groups, and we're going to compare them and see whether we can make a conclusion that one is different to the other. So let's write that as our null hypothesis and alternate hypothesis. So the null hypothesis is the one of no change. It's kind of boring. So in our case, it's just going to be that the birth weights mu1 in smokers is equal to the birth weights mu2 of non-smokers. So mu1 equals mu2. So H1, our alternate hypothesis, that's the kind of interesting one that we want to investigate. So it tells us that we're interested in whether mothers who smoke have less birth weights than those who do not. So that's going to be that mu1 is less than mu2. So average birth weight from a smoker is less than average birth weight from a non-smoker. Alright, so the next thing to look at is alpha and what our criteria will be on then accepting or rejecting our null hypothesis. So alpha, it tells us up here that it's equal to 5%. So if I use the p-value approach, then what we know is that the p-value that we calculate, if it's less than alpha, that's going to give us a lot of evidence that we can reject the null hypothesis. And instead then we would conclude that yes, okay, one is less than the other here. So the opposite case is if the p-value ends up being greater than our alpha, then we don't have enough evidence. So we're going to accept HO then and say, yep, they really are just statistically equal. Alright, so now I'm going to go into my samples and I'm going to look at a few different properties. So let's pull a sample here, and that's what's in our spreadsheet. I'm going to call it sample 1. So what we should be able to figure out is N1, that's the number of observations within the sample. We should be able to also get X bar 1. This is going to be the average of all the observations in the sample. And the last one is S1, and this is going to be the standard deviation of the sample. Now we should be able to do the same thing for the second one, so I'll call that sample 2. So we'll get N2, X2 bar, and S2 as well. Alright, so we need to go over into our spreadsheet, which I've got here. There's a couple of ways that you can do this, but I'm going to do it by formatting my data as a table, and then I should be able to sort this smoker column to be the yeses and the nos, so that's the smokers and the non-smokers, and then from there I should just be able to copy the birth weights relevant to those two different groups. So I'm going to start by making this whole thing into a table. So if I highlight it and go into the Home tab and then Format as Table, I'll just pick the first one. Okay. And then I want to sort here. So if I go to here, let's start with the yeses. So that's going to be anyone who's a smoker. So what it should do is just filter to only include the observations that answered yes to this question. And then I'm going to copy the birth weights in this final column for that group of people. So copy, and I might paste it in a new sheet. Pop it here. And this I'll call smokers. Alright, so let's now go back and do the same thing for non-smokers. So that's just going to mean changing this over so that we get all the people that said no rather than yes. Click OK. So it's changed over, and again we should be able to copy this last column here for the birth weights of that group. Just paste this so it's a bit nicer formatted. So this is the non-smokers data. Alright, so what we want to get out now is the mean. Pop it in here, so that's X bar. the standard deviation, which is S, and also the number, which is N. So that's for our two groups of smokers and non-smokers. If you wanted to, you could also do this in a pivot table, I should mention. So getting X bar, that's just like the average that we want to look for. So let's highlight all of our observations for smokers. Here we go. So we got about 3,373. If we do this for non-smokers, highlight them all. Remember to hold shift to be able to do it that way. So they've got an average of 3,647. All right, next was my standard deviation. So STDev, and I want to pick the one that's .s because that's based on a sample. So again, we just want to go through and highlight all of our values for the two different groups of people. So this one, and then again for the others. Cool. So that's my two standard deviations. And finally, I just want the number that's in each sample. So one of the things you can use for that is count, although you could probably just look and see as well. But this is just going to count how many cells have values in them. So I think I probably should get 390 here, since the first row was a header. Yep. And then here, really it's just going to be the difference between 1,000 and what we got for the previous category. But anyway, that works out to 610. So again, this is just one way of getting that data out. You could also use a pivot table or other things as well, like a calculator as well. So let's just pop these back over in our working. So this is 390, this is about 3373, and this one's about 529. Then we got 610, about 3647, and about 525. Alright, so our next step now is to try and look at drawing a diagram of our distribution of x1 bar minus x2 bar. I'll just put if x1 and x2, so these are the random variables representing the birth weights in population 1 and birth weights in population 2. So if these are normal, which we're going to assume, then the difference in sample mean between the two of them should be normal as well. And we know that a normal distribution can be described with a mean and a standard deviation. So the mean of this random variable, x1 bar minus x2 bar, it should be equal to 0 if we're assuming our null hypothesis where they're equal to each other. Okay, if they're equal, the difference between them is nothing. So that's that one sorted. The other one that we have is the standard deviation of this variable. Sorry, put in a minus. And this one depends on your variance assumption. So I talked about in the recap video how you needed to look at the variance of your two different samples. Okay, so sample 1, we've got, well, here we've reported standard deviation, which is 529, and here we've reported the standard deviation is 525. Just remember that the variance is equal to standard deviation squared. So here we can see that these values are very close to each other, so that probably means that we can assume quite easily that we have equal variance. However, if they were quite different, then you may not be able to make that assumption. And we had a rule of thumb which we could apply to decide whether our assumption was valid. And the rule of thumb was that we could assume equal variance if the if the variance of one over the other was less than 3. I mentioned this needed to be the bigger one over the smaller one. Okay, so in our case, S1 was bigger, so 529 over 525. So if you sub that in, 525 squared, what you find is this is about 1.01, so that's definitely less than 3, so that means it's valid to assume equal variance between our two populations. Alright, so we could actually calculate this if you wanted to, and I gave you the equation for it in the recap video. Otherwise, it's probably easier just to get Excel to deal with that for us, and that's what I'm going to do in this video. So let's draw our distribution. So what we're looking at is this variable, x1 minus x2 bar. We said it's normal, so it should look something like this. It's got a mean of 0, and the standard deviation, we haven't calculated the actual number, but it's represented by that variable. So what we are interested in is a specific case of x1 minus x2 bar, and that's going to be the difference that we can get out of our sample. So x1 bar minus x2 bar from the data that we have got. So that's going to be this 33373 minus this one. That gives us negative 273.7. So if we pop down here, this is 0, we're on this side of it, negative 273.7. So what our p-value is looking at the probability of this situation occurring that we got from our data, or something more extreme. So the more extreme is going to be this left-hand side here. It's further away from the mean. So we need to figure out what percentage is inside this region. That's what the p-value actually is, and that's what we can compare to alpha, like we have up here, to know whether we can accept or reject our hypothesis. Alright, so to get this out, what we need to do is convert it from this variable into being t. And we know that when we do that conversion, the 0 is going to go to 0, and this value is going to get converted using our equation where it's like t equals x1 bar minus x2 bar minus the mean over the standard deviation. Now I'm actually going to get Excel to do this calculation for us rather than us bothering it. And that's really just because I can't be bothered going through and finding out this standard deviation on the bottom line manually. Alright, so let's go and find in Excel. So if we go into data and this data analysis, so what we need to pick out of here is the correct test. So we said we're going to assume equal variances, so we pick this one. If you had to assume unequal variances, then you would pick the second one. So that's ours. We hit OK. So what we need to put in here is firstly the variable range for variable 1. So that's just going to be picking up all of our smokers' values down this left column. Yep. So highlight all those. Variable 2, that's going to be the second column for our non-smokers. So let's highlight that. Yep. All the way down. Alright, next we have the hypothesized mean difference. So that's going to be based on our null hypothesis. And we assumed up here that HO, mu1 was equal to mu2. So again, the difference there is going to be 0 between them. So that's what we pop in here for our hypothesized mean difference. We have alpha is equal to 5%, so that's 0.05. And the last thing we need is to give it where to put our results. So I'm just going to click in here, output range. Let's say that we want it here. So click OK. And it should give us our results. Make this a little bit bigger so we can see. Alright, so here it's calculated for us the mean, the variance, which is the square root of, which is the standard deviation squared. It's counted for us how many observations were in each group. And this is the pooled variance. So this is like the variance when you consider equal variances. We've got our hypothesized mean difference. Alright, we've then got the degrees of freedom. And this is where it gets kind of interesting. So t-stat, this is the t-value that it converted our negative 273 or whatever it was to. So if we just dump down here, this value here, it equates to negative 8 approximately in t. So let's pop that here, negative 8.02. So what we were interested in is the probability of sitting in this region. So you could write this as the probability that x1 bar minus x2 bar is less than the negative 273.7. And when you convert it to the t-scale, it's going to be that t is less than that 8.02. So we're going to be able to get this out of Excel. If we jump over, this is the line that it tells us in. So this is the one tail test, which is what we have because there's only one tail here that we're calculating an area of. If you had a second tail on the upper side, then you would do a two-tail test. But we're one tail, so this one here, let me highlight it. So this here is telling us the probability of sitting in this region here. All right, so it was an incredibly small number, 1.45 by 10 to the negative 15. So incredibly small value. So this all equates to our p-value. Right, so now that we've found the probability of this event occurring or something more extreme, i.e. the p-value, we can go back and look at our criteria for a decision. So we said that if the p-value was less than alpha, we would reject the null hypothesis. So that's exactly what we've got. Our p-value is incredibly small, this 1.45 by 10 to the negative 15. It's less than alpha, which expressed as a decimal, it would be 0.05. So what this is telling us is that we have strong evidence to reject HO, and that means that there is evidence that the birth weight of non-smoking mothers is greater than smoking mothers. All right, because this here was our alternate hypothesis. All right, this one was less than this one. All right, so that's all there is for this video, and I will see you in another one.